tried to show that the circular functions had a natural outgrowth in terms of nature. You recall that the circular functions were motivated in terms of simple harmonic motion. The circular functions would have been invented when we talked about motion in which the acceleration was proportional to the displacement, but in the opposite direction. Let's see what happens when we work with the hyperbolic functions. See, suppose now I have a particle moving along the x-axis, okay? And I know that its position at any time t is sinh of kt, where k happens to be a constant. What is dx dt? The derivative of sinh u with respect to u is cos u. So the derivative of sinh kt with respect to t would be cos kt times the derivative of kt with respect to t, which is just k. In other words, the chain rule again. Okay? Now, knowing that dx dt is k cos kt, d2x dt squared would be what? The derivative of cos kt is sinh kt times the derivative of kt with respect to t. That gives me another factor of k. And therefore, the second derivative of x with respect to t is k squared sinh kt. Now, remember what sinh kt is. We started with the knowledge that sinh kt is x. Therefore, replacing sinh kt by what it's equal to, we wind up with what? The second derivative of x with respect to t is equal to k squared x. See, no minus sign here. What happens when we start with the sinh? If an object were moving according to the rule x equals sinh kt, its acceleration would be proportional to the displacement, but in the same direction. You see what that means? That means the bigger the displacement, the bigger the acceleration, so the faster the object keeps moving. In other words, this thing would move at a faster and faster rate away from the origin, etc. That's not our main concern here. What is interesting, though, from a physical point of view, and we can use this as a summary from a physical point of view, is that the hyperbolic functions serve as a solution to the equation d2x dt squared equals k squared x, where k is a constant. The circular functions, on the other hand, solve the equation d2x dt squared is minus k squared x. In other words, from this point of view, notice again, from a physical point of view, that the difference between the circular functions and the hyperbolic functions are, again, just a difference in sign. As I say, this will be emphasized more in the exercises. The obvious next lesson, I think you can see it coming by this stage in the game, will of course be the inverse hyperbolic functions, and we'll see why those are important next time. But until then, goodbye.
Funding for the publication of this video was provided by the Gabriella and Paul Rosenbaum Foundation. Help OCW continue to provide free and open access to MIT courses by making a donation at ocw.mit.edu/donate.